Good morning, students. Today we are going to see about the Newton's second law of motion and its applications, followed by an interesting case study. We all know that Newton's first law. What is Newton's first law? We will be able to answer. When an object is in rest or in uniform motion, unless and otherwise an external force acts on it. We have solved a few problems based on this concept. Now in the unit 4, we are dealing with kinetics. Here we are studying about the concept of kinetics and kinetics. In both the cases, we are studying about a moving object. An object moves because the force is applied on an object. In the second part on the kinetics, we will study about the moving object, which the force causes the object to move. We are studying about the forces. Here, the Newton's second law plays a major role. Can someone say what is Newton's second law?
Force is equal to mass and mass.
Yeah, very good. Force is equal to mass and mass. It's a formula. I want a statement from someone.
Force is equal to the rate of change of momentum.
Very good. Force is equal to the rate of change of momentum. Here, just see, look at this image. In the first case, an object, a single object is kept, a man is pulling. Whereas in the second case, when another object is kept over there and two other persons are pulling. In the third case, more load is there, one person is pulling the object. Which one will be more easy? Second case. Why second case?
The equal the mass of the two persons are pulling.
Yeah, the accelerations are increasing. From the image itself, we know that the acceleration will get increased because of the pulling force. The pulling area, there are two persons involved. So, what you say is F is equal to mu. That is the formula. Here, how we are arrived at this is the change in velocity. mv minus mu by t. That is initial velocity, final velocity. Whereas for initial velocity, we use the symbol u. Whereas the final velocity, v. So, change in velocity. That's what given as the statement. mv minus mu by t with respect to time. So, v minus u by t will be a. We know that v is equal to u plus a formula. From that, we will get a as v minus u by t. So, we derive the formula f is equal to a. There are 4 applications over here. I want you to explain about each application. Someone can explain about the racing car. Yeah.
Yes, sir. Racing car we apply the Newton's second law, two equations. First is braking or the acceleration. So we know that the force is directly proportional to the acceleration. We got from the so the braking force is directly proportional to the acceleration. So when the car is moving, so we have to stop. It means we have to apply the force against the motion. So the car deaccelerates or stop unsafe.
Very good. Just I want to add some point of view. Whether the racing car will be equal weight for the normal car that we are using, will be both the car speed will be matched. Why? To race. It made to race. So that the what will be the weight of the racing car? That will be a more higher or lower when compared to the normal cars. Lower. Yeah. When we reduce the weight, we are able to maximize the speed. The concept of racing car to maximize the speed. So that we are able to achieve more. If we are doing a minimum acceleration, we are able to reach maximum distance. That was the concept of designing a racing car. What about the keeping of a ball?
We keep the force about the force on the ball.
What is the main agenda of the penalty game? Either you want to score a goal or just you want to keep the ball. Score. To score a goal, the ball which we keep it should cross the goal, so that we have to focus where we have to keep and the maximum accelerations that what we want to keep. By this will be able to score a goal. Riding a bicycle. Yeah, very good. When we apply more force on the pedal, we are able to reach the maximum distance. If we reduce the effect on the pedal, then it automatically gets slow. What about the car crash?
During a car crash, the car undergoes sudden deacceleration. Newton's second law helps to calculate the force experienced by the car and the passenger inside the car. Here
Just I want to throw a question to you all from the statement what you have given. If there is more number of persons in the particular car, how the crash, whether more damage to the car will occur or there will be minimum damage. More number of persons, more weight. Minimum damage, yeah. That's what we said. If the weight of the car gets increased, there will be a minimum damage. That's why while we designing the passenger's car, we'll consider weight. We'll not try to reduce the weight. Whereas when we go for the race car, what he said is that the main concept is to reach the destination at highest speed. So there we will reduce the weight. Whereas when we come for the passenger car, we will not consider to reduce the weight. We'll maintain a standard weight so that if a car accident happens over there, we can minimize the effect. We will see a problem. Before that, just I want to say that during a crawl crash, what is a vehicle that is moving at high speed will try to stop at a particular point. The sudden stop might occur. Will apply the sudden brake. According to the Newton's second law, the force experienced by a passenger is proportional to the mass of the passenger and acceleration or deceleration during the impact. That is applicable earlier. When a vehicle suddenly stops, the body of the passenger wants to continue moving forward. In this case, when we apply a sudden brake, the vehicle stops immediately. The passengers will come forward. That's why we designed the airbag so that the passengers who travel inside the vehicle will not get any impact on the car itself. So that's why we are designed for an airbag. We might have experienced in the bus while we travel, the driver applies a sudden brake, will move forward. That is happened because of the force of inertia. Just look at this problem. A constant retarding force of 50 Newton is applied to a body of mass 20 kg moving initially with a velocity of 15 meter per second. How long the body will take to stop? Just we can work out and give the answer.
So in the given data we have the force 50 Newton and mass 20 kg. So we know the formula V is equal to U plus AT. In that formula we don't have acceleration. So from the given data we can calculate acceleration. So we know that F is equal to M into A, A is equal to E by U. So F is 50, so M is 20. We get acceleration as 2.5 meters per second square.
V is equal to U plus A. The way you follow V is equal to A. What will be the V? Yeah, very good. Since the car gets stopped, the final velocity will be 0. By substituting the values, what will be the T? Yeah, good, very good. Thank you. This is how we have to calculate the real industrial cases when we go for industries. Thank you.